Okay. Our next talk is from Stephanie Jensen, who is a coder of over 12 years, from two-person startups to Fortune 500 companies. A huge fan of self-taught coding. Stephanie's talk title is No RAGrets. Please welcome Stephanie Jensen.
Perfect, okay. All right, can you guys hear me? All right, sounds like you can. Okay. All right. No RAGrets, Retrieval Augmented Generation, or How I Learned to Stop Worrying and Love AI. All right, my goal for this talk is to get you guys so that you are familiar with the concept of Retrieval Augmented Generation, as well as knowing what questions you need to ask and whether or not it's going to be a good fit for your application. All right, so for context, I built this Retrieval Augmented Generation at the company of Dynata. They are a large data aggregation company. They collect stuff for marketing, for politicians, all kinds of stuff. Some people don't like it because they get phone calls of them if they're in swing states. But luckily, though, I don't have much to do with that. I work for a completely separate product called Sharper that was originally started with the help of Ken. And they are a knowledge management platform that centralizes documents, reports, and videos. The best example I've heard is kind of like Pinterest, but for market research. All right. What is Retrieval Augmented Generation? So essentially, it's a way to connect LLMs to large data sets. So databases, data lakes, I mean, really whatever you want, you can probably do. Most cases that I've seen it is using databases, but a few have used data lakes. All right, what are the benefits of a Retrieval Augmented Generation system? You want your app to use the most up-to-date and accurate information. We all know LLMs are trained on somewhat outdated data, and sometimes they can get some more recent data by using Google searches or other web searches. But not everyone's data is on the web for good reason. So this is a great way to essentially make sure that you can get proprietary information as well as the most up-to-date, assuming that you're keeping track of that and making sure it's good. You're having issues with LLMs hallucinating. One of the big benefits to using Retrieval Augmented Generation is you control the sources that the AI uses. It can also be used to cite the sources that the AI uses, so that way you can double check to make sure it's telling the truth. As we heard in the last talk, you can never get 100% with AI, unfortunately. And then you also want to have a natural language processing interface for your database, so that people can just write questions instead of having to come up with complex searches with filters and exclusions and all that other stuff. Some examples of people using Retrieval Augmented Generation. So AstraZeneca is using it for pharmaceutical research. This is the one I have the least amount of information on because a lot of their stuff is very proprietary and they don't want people to know for good reason. But they're using it in similar ways that we're doing, but just for pharmaceutical. NASDAQ uses it for market research. They actually allow their customers and clients to access, essentially, say, like, I want to see the latest trends on coffee production in the last year, and buying or stock prices in that regards. It will go search through all that data, all that economic data, and return it back to the client. Adobe uses it for customer support. So they essentially uploaded all their knowledge bases, facts, customer support stuff, and so that way then when people ask questions about how to use their software or problems that they're having, they can go through their AI, and not all that information is always necessarily online. Royal Bank of Canada. So they use it for contract policy management, and that essentially, from what my understanding is they essentially use it to go through their almost century worth of contract data to find similar wording in contracts where it's not necessarily the exact same words, but you want to find similar ones so that you can compare and contrast for new and upcoming ones, as well as finding other examples of it. All right, so let's break down Retrieval Augmented Generation into its parts. So you have the first part, which is the embedding LLM. So these are usually a smaller, lighter weight LLM that's not really capable of much reasoning. but it is able to take in data and convert it into a hyperdimensional vector. We'll go over those in a little bit later, but it's essentially a way of ingesting something like data like text, images, videos, whatever, into something that the AI can process and compare against. You then take those hyperdimensional vectors and you put them into a vector database. So this is essentially, this is like really all a vector database looks like is you have some metadata and then you have a long series of essentially floating integers. And then once you get to the final part, which is the actual LLMs that we use all the time, like ChatGPT, Claude, whatever have you, and this takes all the data from the vector database that is found and processes it into a response that a human can read and understand. One of the best examples I've heard of this whole system is you have a librarian and a reporter. So the reporter wants to write an article on something and goes to the librarian and says, I need information on this subject. The librarian then goes through all their books and all their stuff, gets it all together into a nice little pile of the most relevant documents, hands it to the reporter reads through them, sits down and composes an article based off of that data. That's more or less what the R.A.G is doing. And for context, the embedding LLM and vector database are more of the librarian, and the generative LLM is more of the reporter. All right, so the embedding part. So this converts, like I mentioned, text, photos, video, probably music at this point too, into 1,000 to 3,000 dimension vectors. So for those of you who have been a long time since geometry class or other math classes, vectors are essentially a line in space. So they're really, we mostly deal with 2D and 3D ones because that's what we can imagine. Can't really imagine something with that many dimensions, but functionally and mathematically, they're very similar. Down below are some examples of embedding things. Just about every AI company at this point has their own embedding model. They kind of need it for their own versions of processing and interpreting data. The ones that I've used the most are the ChatGPT one and the AWS Titan embeddings. This is an example. So kind of how to think of it when it looks at something. So one of the kind of crazier parts, and this kind of brings some little bit of existential dread to me, is that you can take any kind of art piece, any kind of literature, and just turn it into a line in space, which is kind of crazy to think about because that line also represents a very solid understanding of that art piece. Not only of what's in it, but even like paint styles. Some of the better embedding models can even get like themes and like that, all from just a line in space. But you can kind of see here, like, if there's a king, it comes out to that. If there's a man or a woman, it comes out to those things, so on and so forth. The benefit to this, though, of why you want things as a vector is you can, so once you get them into a vector and you put them all in one place, you can then query and search that place, which we're all very familiar with. We love putting data into boxes and doing stuff with them. And this is an example of vector-based rendering back in the day, I think, at least. But yeah, so some examples of some more popular vector databases that one can use to start. Postgres, Pinecone, Cloudflare, AWS Bedrock, Llama. Even MySQL is working on adding a way for you to incorporate vectors into existing databases. Obviously, you'll have to upgrade your version when it comes out, but from my understanding, you can just make tables now that have vectored information and can be queried to get your information back. So how does one query a vector? So it's just like comparing two-dimensional or three-dimensional lines, obviously with many more steps and a lot more math and thinking, and you probably don't want to do it yourself. So yeah, you take these things, and you're essentially trying to see how parallel they are, because the more parallel these lines are, the more similar they are in what they are talking about. If they're perfectly parallel, chances are they're the exact same thing. But since we have, on average, of 1,000 to 3,000 dimensions in these vectors, we have to use heuristic methods, which means close enough. The most popular one I've seen is nearest neighbor search. There are a few others, but I'm not a mathematician and I'm not qualified to speak too much to their merits and whatnot. But it is important to know that most of the time when you're going to be searching, because if you do an actual true comparison of all these vectors, if you assuming you have thousands of documents or thousands of entries to go through, it could take hours. Nobody has that kind of time to sit there waiting for a response from their thing for hours. So these heuristic methods also save computing power. But it is important to know that they are not going to be perfect. They are approximations, but they're pretty good. We haven't had too many issues with them returning anything fishy. I would actually arguably say they're not the least reliable part of the LLM, is usually the more problematic part. All right, so once we put the information in with the embedding model and we start querying the vectors, then we get to the LLM generation part. So this is where it takes all that information, like the reporter I said, puts it all together, takes the most relevant pieces, and responds. So there is going to be some prompt engineering coming in here. You're going to have to give it instructions saying, I want the output to look like this. I want you to avoid doing this. We all have done it, or at least most of us probably have. And I do recommend, as with any LLM thing, it should usually be facing a person so that they can verify that it is correct, or at least not saying weird things and doing weird stuff. Another thing I should also mention is that embedding also comes in with the question. So how it compares those vectors is the person will ask a question, like, what is the latest trends in coffee purchases, like I mentioned earlier. We'll convert that into a line and compare it against the lines that are the documents in the vector database. And that's how it finds the most relevant one. All right, so the project that I worked on with Retrieval Augmented Generation was for the company Sharper. And we essentially have tons and tons of research articles for market research mostly. So we wanted a way to be able to search through those and incorporate it with AI. We started doing AI stuff earlier with summarizing the articles, and it worked really, really well. And so we decided, why not look into this retrieval augmented generation? I think we'd actually seen some articles on it. I think I was the one who brought up part of it. But yeah, so we started with an AWS S3 bucket full of documents, PDFs, docs, whatever have you, text files. And then we also had a bunch of metadata and transcriptions for those documents in a MySQL database. We also had a very robust and well-made Elasticsearch system, but it was outdated and we couldn't update it because currently Elasticsearch does allow vector databases, but we were about 4 versions behind, and it was determined it was too much effort to try and upgrade it. But we are actually now doing that. So the first thing we tried was the Postgres vector database. Very nice. It was very easy to start up. Really quite handy. And then we also did ChatGPT at the time, because literally 2 years ago, that seemed to be the best option. And then also use the OpenAI embedding model to start putting things into that Postgres vector database, as well as parsing the user's questions. One of the issues that we had with this setup is that there was a lot more back-end work for our DevOps people. And we actually also got approached, because after AWS found out that we were doing this, they mentioned that they had started their own product for retrieval augmented generation called AWS Bedrock Knowledge Base. Really quite nice. It's all self-contained. Like everything, you just simply say build it, builds the database, you pass it in and interact with it all through API calls. It was very much more simple, a lot less work, and we were already using AWS at the time, so it just made a lot of sense to go ahead with it. So we ended up using them. We use their Titan embeddings model, which when we started was considered to be one of the better ones, but other places have caught up now. Things are always changing. And then we also use Claude Opus for the LLM. So that's the actual like reporter answering part. Okay. All right. So that's enough talking about retrieval augmented generation. Let's see it in action. All right. So this is the Sharper product. This is the home page. You can see all these documents here. This is a demo, so none of it's actual like customer data or anything. But you can see here we have quite a few articles on spending habits of millennials. And so we can actually go to our fancy thing, we call it Answers Engine, because you ask it questions and you get answers. All right, and so I have a preloaded question here just because I wanted to make sure everything worked and looked nice for a presentation. I ended up making this whole front end, did a fair amount of the back end. Really the only thing I didn't do too much of was the DevOps side of it. And you ask it the question, some fancy loading and thinking animations. It does take a few seconds because, like I said, even though it takes hours to do a true comparison, it still takes about a minute to do the heuristic comparisons. And let's see. And there we go. So we asked it, what are millennial spending habits? And you can obviously do more detailed questions like, what are the latest millennial spending habits? What are millennial spending habits regarding coffee? If you have the data in your vector database, chances are it will find it because it doesn't do keyword searches, it does semantic search. So it goes based on intention rather than actual keywords. And so you can see here it breaks down the question or the answer, and it also cites its sources. This is probably the biggest thing that we like the most about it, is that you can actually see where it got its information from. You can even, with the AWS version, highlight the individual parts of the text that are in the response to the parts of the documents that it said it pulled it from. We did have a few cases of that not perfectly lining up. So that's kind of why we kind of didn't do the exact parts of the text, but just did the paragraphs, so to speak. And you will see some documents are referenced multiple times. So when the vector database is pulling stuff, it doesn't pull the whole document. It pulls a chunk of the document because it can't. We all know about the context windows. Can't think about a whole book at once. So you send it a couple of pages at a time, and so it will then pull those couple of pages at a time. But you can have it pull adjacent pages as well if you want to give it some more context. And yeah, so this is the thing we like most about it, is that if it is something that does seem fishy or doesn't seem right, you can go check it to make sure. Okay. Come on. All right, and that's pretty much the whole demonstration of retrieval augmented generation. Hopefully you guys now know what it is, how it works, and what you can use it for, and if it's going to be right for your guys' application. That's my name, and that is my personal email address. I've had it since high school because people always remember it. And yeah, I have some time for questions. I imagine there might be a few. Yes?
Did you experiment at all with re-rankers after you gave your response back from the vector database?
So the vector database, oh yeah, sorry. So he asked if we used re-rankers, and I think I know what that means. It's like where you're re-prioritizing the documents. So with the vector database, one of the cool things is that it will actually rank them based off of how similar they are, because of how more parallel the lines are. So it already comes in pretty well ranked. And you can also tell, so like you noticed how, let me go back to the, so some of these get referenced multiple times. That's another good way to know like how relevant a source could be, I'm assuming is what you're trying to check. So if it's using a source multiple times, chances are that source is really good for the question you're asking. But it already kind of ranks them approximately based off of how parallel they are. So we haven't really had a need for that. Yes, back there.
You went from ChatGPT to Claude. What was the determining factor there?
Because AWS doesn't offer, oh, sorry, he asked why we went from ChatGPT to Claude. ChatGPT worked fine. We had no issues with it really, I mean, other than standard LLM issues. The big reason is that AWS does not support Claude, or does not support ChatGPT, but only supports Claude and their own models. And so it was just easier just to switch over to that. And we really haven't had any issues with it. Really, we had to tweak some of our prompts and been fine ever since. Any others? Yes, back there. Ah, okay. So, sorry, I keep forgetting that. You asked what the prompt was that we used for this question. I don't know if I can show it all because we do have a lot of proprietary information, but I can give a brief summary of it. We ended up settling with one that says you are a market research assistant. You are looking to try and be a helpful market research assistant that is trying to find relevant data and present it in a concise and thorough manner. Something along those lines on the thorough part. I can't remember. We played around with a lot of synonyms and found one that it really liked the most. It's mostly kind of more defining its role, and then the format. We also specified we wanted it broken out into various text blocks depending on the parts of the question and the documents referenced. That probably took the most, is getting it to do consistent formatting. We just had a lot of issues with it sometimes just being like, here's a big paragraph, here's numbered points, here's bullet points. But we eventually got it so it works. I think actually we haven't had any issues with it breaking lately, but once again, it's never 100%. Yes?
Are you using a tool to evaluate response quality over time? And so what tools have you found out for that?
We have looked into those. AWS has started to do a lot more things in terms of like guardrails and kind of like having AI check itself, but we're a little skeptical of having AI check its own work, just because if it failed once, what's to say it's not going to fail again? Mostly we've been getting is just customer feedback and a lot of using it, which has been pretty positive. We're actually planning on converting this over to our main search function in the future, because we found that people tend to find it a lot easier to use because you just don't need to worry about filters or Booleans or anything, and end users oftentimes don't even know about those. Any others? All right. Well, I think we're good? Okay. Yeah, let me know if you can reach me and find me for any other questions.